Fearless factoring. What a great name. Okay, so we're going to do fearless factoring, and this is normally called a perfect square trinomial, which what they're saying by that is when you get to your factor form, you're going to end up with a bracket and a bracket, and they're going to be the exact same thing. So instead of writing them as brackets beside each other, I'm sorry, I'll do it over here. We'll do brackets and a square up there, meaning that both brackets are the exact same. Now, there are shortcuts to do that, but you can also use the exact same methods you've been always using to solve it. So let's do that. We're used to fearless factoring, so let's just factor it the exact normal way. So fearless factoring, we have to know what our A term is. This is our A, our C term is, and our B term. And we need two numbers that are going to multiply to what A times C are, okay, or is. I don't know if I said that right. And then those same two terms need to add up to whatever our middle B term is. Okay, so 4 times 25, very nice, gives us 100, and our B term is 20. So usually the best way to eliminate this is to look for factors over multiplied. So we need two numbers that multiply to 100 and add to 20. 2 and 50, they multiply to 100, but they don't add to 20, so not going to work. 4 and 25. They multiply to 100, but they do not add to 20, so not going to work. 5 and 20, they don't really work either. 20, what else are we missing? Oh, there it is, jeez. And then there's, of course, I should have known this from the style it is, 10 and 10. 10 times 10 and 10 plus 10 work out. So those are going to be our two terms. So we'll write them in permanently here. 10 times 10 and 10 times 10. Great. So now for fearless factoring, what we do is y is equal to, and we've set up two sets of brackets, and the first term, so the coefficient and just 1x, we don't include the squared, the 4x is going to be the first term in both brackets. Okay, so write in red to remind you that it's the a. 4x and 4x. Okay. The second term in each bracket is going to be 1 and 2. And normally they're, well, not normally, but a lot of times they're different values. Okay. In this case, they both happen to be positive 10, so we write positive 10 in one and positive 10 in the other. And finally, in the setup, we divide everything by the very first coefficient, which is just that 4 again. So we take that 4. Right? The next step is to work on common factoring. So I need a common factor that comes out of at least one of the brackets, if not both of the brackets. And since both of the brackets are the same, whatever is going to come out of one is going to come out of the other. Can you think of a value that I can divide both of these two by? 2. Perfect. So I can divide 2 from this one and from this one here. So when we do that, okay, think of it like we divide this by 2 and this by 2. And then we do the same thing here, divide by 2 and divide by 2. So we have 2 bracket 4x divided by 2. Do you know?
2x.
Yeah. And then 10 divided by 2.
5.
Perfect. And then we just repeat that on the other one because the brackets happen to be the exact same. Okay, so 2x plus 5. Still all divided by 4. And there's a rule in multiplication. And what it says is it doesn't matter the order you multiply things in. Where's that pen? There it is. You always get the same answer. So for instance, if I do 5 times 2, you know what that equals?
10.
Yeah. And what's 2 times 5?
10.
Yeah, it didn't make a difference. Okay. So I'm going to rearrange the order. I'm going to pull this 2 to the front and multiply the 2 together. What would 2 times 2 be?
4.
Yeah. So now we have 4. And then I'll leave the other two brackets. Plus 5. Plus 5. Still all divided by 4. And what works out really nicely here is because we have 4 on top and 4 on the bottom, they cancel out or create a 1. So they're gone now. And we're left with just our factored form. Y equals 2x plus 5. 2x plus 5. Now, this is why this is special. This is because they're the same, so we can just write it as 2x plus 5 squared. That's it. We can use the exact same method we've always used. We don't have to memorize any new shortcuts. The shortcuts are faster, but as long as we recognize when they're the same at the end, I just make them squared, and I've done everything they asked me to do.